Hi, we are discussing about microservices in this video. We all know that microservices architecture is one of the trending architecture nowadays that most of the companies are implementing it for building complex application, enterprise grade applications. We are using microservice based architecture. So here Spring Cloud, and Spring is providing rich set of features for building microservices. And we can say Spring Boot is having many built-in features to make it easy to build and run your microservice in production at scale, right? So that is why the microservices architecture is very important. So what are microservices? What do you mean by microservice? A microservice is a self-contained, independent, single responsible service. That means we will create a service for performing a single responsibility that will have single responsibility, single purpose. For example, you take um, banking sector. In banking sector, we can divide multiple functionalities like withdrawal is one functionality, depositing in one functionality, account summary is one functionality, the funds transfer is another functionality. So for every functionality we need a separate service, nothing but a microservice. It's nothing but some RESTful service. Why we are calling it as a microservice? Because it is performing single functionality. It is doing single job. Withdrawal is a single job. It is not having any other functionality along with it. So that's how we are actually dividing and modularizing the functionalities into as per the domain driven model. So that is why the microservices architecture is one of the best architectures. We follow it to build very complex applications as well, right? As we already spoken about it, Spring is providing many features. Spring Cloud is also providing many features. So we can build resilient microservices using Spring Cloud. Here you can see the diagram. I can explain you. You see there are multiple services. Spring Boot apps are there, and we have API gateway, and you can see features: cloud config server, service history, circuit breaker download, and Spring Cloud Sleuth. Okay, the message brokers, databases, all these are the features of the microservice. Okay, I will explain you what is here API gateway, config server, and service registry, circuit breaker, Spring Cloud Sleuth. I will explain that to you. API gateway, we require API gateway as a separate independent service. It is also microservice, but inside this we will configure authentication, authorization, and logging, routing, load balancing. We will configure all these cross-cutting scenarios in this service. Why we need all these service to be separated? Because as we already discussed, every service has to perform a separate, independent, single responsibility, each microservice. So that is why all these logging and security related and tracing, routing related, load balancing related, these activities and these configurations we actually do at API gateway service. So API gateway service is a separate service which will have all these cross-cutting concerns and all these different kinds of configurations. So when request comes to the API gateway, and from there the request will be routed to the respective service, right? Respective service. So you can see there are three Spring Boot services are running, and I want to tell you what is config server, okay, and service registry. And you see the config server is nothing but a separate service where we actually store all our properties in remote repository location. We don't need to store or save all the properties, configuration properties along with any service or application gateway. Rather, we put all these application properties in a remote repository, and those properties will be fetched from the remote properties by this config server, and they'll be loaded into the application configuration files um, at runtime of application. So that way we use the config server. Basically, config server is used to store and manage the configuration properties of an application. Service registry is another kind of service. Basically, we are designing multiple service. We may create multiple independent services, right? Then when application gateway wants to communicate with any of the other service, or any other service wants to communicate with any other service, it needs to invoke that particular service by using its URI, right? By using its URI. So service registry is the registry where each and every service, a microservice, will be registered as a client, so that it will get some IP, some address will be allocated for it dynamically, so that whenever the communication is happening among the multiple service, these services will be recognized automatically using by that service registry address. So that way the service registry is a registry which will contain all the addresses of each and every service, IP address and each and every, and which port it is running. So that way the communication among the services will be easy, and each and every service will be identified dynamically at runtime. Okay, that way it makes the process of communication among the services. That is why we require a service registry. Circuit breaker is a design pattern. Why we use circuit breaker dashboard, and I'll explain that to you. So basically, when we are designing multiple services, sometimes some service may goes down, right? It may not work because of network issue, some other error or exception reason. So that time, when another service is invoking that particular service, but other services went down and it's not working, then it may get a response, improper response, or it may wait for some time, right? Because the server is not responding with the response. So to handle those scenarios, we need to handle the fallback mechanism. Whenever some particular service is down, or because of some issue, network issue, other issue, something is not working, that time, if in case any other service is trying to invoke that service, it will give the basic fallback information, stating that this particular server is down, so these are the basic details like that. For example, you take in banking application, when a client is invoking a particular account summary details, but the service is down, right? So then it will return with the basic information, with the basic static information, um, basic static information. So internally in the background, it keeps on try to check the status of the service which went down. As soon as the service comes online, and then that it will fetch the actual response and it will display the response there. So that's why in the fallback mechanism, we actually write the fallback methods, and what should we do in case of something goes wrong, what kind of fallback information should be shown there. All this detail we will configure in the circuit breaker service. We use the circuit breaker pattern, we will specify there. So, and Spring Cloud Sleuth is a kind of a distributed tracing mechanism, because we need a logging system, proper logging system, and proper basic tracing system. Because when we are building lots of services, let's say if you want to build hundreds or thousands of microservices. If it is a complex system, then you have to build or you have to configure proper logging and tracing system. Spring Clouds with it actually provides us basic logging configuration mechanism where we can actually get a trace ID and span ID for every request, and we can also see how the request is floating from one service to another service, and how the control is going from one service to another service. All these details can be displayed on a visualization UI if we configure this Spring Cloud Sleuth. So this is one of the features, right? So that way Spring is providing many features. So Spring Cloud is providing rich set of features. We also have uh, other features. Not only this, we have many other services. Let me discuss those as well in high level. Okay. We can simply what is the advantage of this microservice? We can simply containerize these applications. You see, whenever we want to containerize any service, we can simply containerize, and we can deploy it in any containers, any cloud or anywhere we can deploy it. So that is the best advantage of this microservices, right? So you can see what are the benefits here, but okay, key characteristics are uh, componentization of the via services. So we are modularizing it, self-contained service, independent deployment. Let's say you actually developed 3 or 4 service for banking application: withdrawal, deposit, transaction, summary, fund transfer. So each service can be deployed independently, each service can be maintained independently without any issue and all, right? This is the one of the best characteristic of microservices. So we can also scale the services. See, if the load is coming to most of the time only account service, see, most of the people, they will check the account status, account information, right? So that time the load may be very high for the account service. Then we can only scale the account service. We don't need to scale other services. So this is also one of the main feature. Loosely coupled, right? All the services are independent of each other. If one service is getting any problem or exceptions and it's not working, it won't impact other services. So technology diversity, fault isolation, so many use cases are there. Faster development, benefits of microservices. So you can develop any application as fast as you can do. See, nowadays most of the people, they are using microservices because simplicity and easy to understand, easy to develop, and easy to build an application without any issue. So increased flexibility, improved resilience, right? Efficient resource use. So I'm telling you, there are 2 ways the services communicate. One is a synchronous communication, other thing is asynchronous. Asynchronous means we use messaging queue softwares like Kafka, RabbitMQ, and other Spring provided messaging systems. In synchronous communication, when a particular service calls other service, it waits until the response is returned back to that service, right? In a synchronous way. But in asynchronous way, the services, they don't need to wait for the response. They'll simply invoke the service and they'll post the message into messaging queue and they'll forget about it, right? So that way we can use the asynchronous architecture also. Depends on the requirement. But there are some challenges. You can see using a microservices, there are some challenges are there. Designing the complex system, designing and managing the communication between many services can be complex. Since you are building and designing many services, it may become very complex or difficult when you want to establish a communication. If it is very large and complex system, right? We do have a third party softwares or communication the features where we can establish a proper communication. Nowadays we are hearing about issue, and also asynchronous communications, so many are there. Other problem is the distributed system issue. So since developers need to handle the challenge that inherit in distributed system, network latency, data consistency across services, it is not a single application, then we have to make sure that it follows the atomicity properties, atomic property, acid properties. The consistency is very important. Whenever an application is doing some operation in the middle, if something was broken, it should be reverted back, it should be rolled back, right? It should be rolled back. If it is not happening, then we may see the consistency issues in application, so we don't want to see that. So that is where we use this some saga patterns, some CQRS, some design patterns are there where they'll resolve these issues under with the microservices. So this is all about it, and I just want to give you a brief about the microservices, and thank you for listening this.